Hello, students, and welcome to Friday Math Happy Hour. Okay, today it's the first semester. I mean, it's the first week of the first mini semester for Math 1324 and NCBN 0324. So these are the topics that I'm going to cover for today, which are really the topics that were supposed to be covered during the first week of this semester. Okay, first I'm going to show you how to navigate through MyMathLab. Then we're going to get into working out some problems, like show you how to graph linear equations, writing equations, parallel lines, perpendicular lines, linear models, evaluating functions, and lastly, quadratic functions. Okay, so let's start with how to navigate through MyMathLab. Okay, now, most of the times when students enroll in MyMathLab, and it's their first semester using this platform, they have a hard time trying to navigate. So hopefully with this PowerPoint or this video is going to clarify some of the issues. So first, you're going to go to www.mymathlab.com. Once you go in there, right, you click it, and this is the page that you're going to see. Okay, now, if you already registered and have an account, you're going to sign in, right? You're going to go there and sign in. If you do not have an account, which is the first time they're going to be using MyMathLab, you're going to have to register. So you're going to go to student. You're going to click there. Once you click on student, it's going to take you to this page here. Okay, you'll need these three things to get started, right? So once you have those three things, once you have 1 through 3, then you're going to hit OK, register. And once you click it here, it's going to take you to this page here. Okay, the instructor should give you it's called like an access code. Okay, the code, I mean not the access code, is going to be like an ID, the course ID for the instructor. For example, mine, since this was from last year, this was the code ISASI 77649. Once you enter that the access the course ID, you're going to hit continue. Okay, once you click on continue, this is the page that you see. Okay, now if you already have an account, you're gonna go in here. But if you're gonna create one, you're gonna click on create. Okay, again, if this is your first time you're using Pearson, you're gonna create an account. Once you click on create, this is where it takes you. Now, all these fields you got are required. That's required, your email address, and prefer to use your EPCC email address. You're going to come up with your username, a password. They want you to re-enter the password, then your first name, your last name. Then they're going to give you a security question, right, for security purposes, and then the answer. And once you do all that, you're going to hit on agree. I agree to the terms. Then, right, you're going to create the account. So you're going to hit create, and it'll take you to this page here. Here's where you're going to have to pay for the access code. Either you're going to pay 104.99, or the $69.99. What the difference between these two is that the 104.99 is up to 24 months. The $69.99 is only for 18 weeks, which is like a whole semester. Now, if you don't have any money at the moment, you can actually purchase a temporary access code, right? Which is right here. You're going to click right here, that link there. Once you click there, you can have free access for 14 days. Okay. Now, once you enter into MyMathLab, this is what you see. So, for example, I'm going to hit on assignments, right? Click on assignments, and this is the assignments that are there for 1324. And the NCBN and the 1324, they both use MyMathLab. So for example, once I'm here, I'm going to hit section 2.1. So if I click it there, this is the homework. If I click at question number 1, right, this is question number 1. This means that it comes from chapter 2, section 1, number 1. That's what the 2.1.1 means. And then you begin working out the problem. Now here, question help, here you have various assistants. Okay, let me go back to previous. when you click here, guys, there's help from the instructor. You can ask the instructor. There's help. There's videos. There's how me solve this. There's a whole bunch of assistance that you can get by clicking on this question help. Okay. Now, I went over enough information to get registered and begin working on your assignments, which is the main objective for the first week. There's plenty of more links that you can use on MyMathLab, but for the sake of time, I just did enough to get you logged in, and also to begin doing some of the assignments. Okay. So now let's start with graphing linear equations. This PowerPoint or this presentation covers some of the most important topics for this week, which is preparing you for the first exam. Because since this is a 5-week course, it's 16 weeks cramming to 5 weeks. So I chose some topics that I think they're really important, but there's much more that I couldn't cover because lack of time. Anyway, we're going to be doing graphing by plotting points. So say they give you the equation y equals to negative 2x plus 3. They want you to graph it. How do we graph it? By plotting points. You're going to make a table. Okay. Most of the times, it only takes 2 points to graph a line. But for the sake of practice, I'm going to choose negative 1, 0, 1, and 2 for my x values. So then I'm going to plug in the negative 1 here for the x. Okay, so let's start off with when x equals to negative 1. So when x equals to negative 1, I'm going to plug in negative 1 here for the x. Then I'm going to evaluate. So I get y equals 5. So when x is negative 1, y is equal to positive 5. Then I keep repeating the process, right? And the point is negative 1, 5. That's the order pair. Now, when x is 0, I'm going to plug in the 0 here for the x. So that's going to give me 3. So when x is 0, y is equal to 3. And again, what's my order pair? Will be 0, 3. Now, when x is 1, I'm going to plug in the 1 where the x is, and I'm going to evaluate. So I get negative 2 plus 3, so the answer will be 1. So when x is 1, y is 1. And the point is 1, 1. Finally, when x equals to 2, I'm going to plug in 2 for the x. So we get negative 4 plus 3, so y equals to negative 1. So when x is 2, y is negative 1. And the order pair will be 2, negative 1. Now let's graph it. So I'm going to plot all these points. I'm going to plot them in here on the coordinate plane. So we got negative 1, 5. So it's going to be negative 1. We're going to go up 5. So it's going to be right about there. 0, 3. 0, 3, right? This is 0 for the x, and we go up 3 for the y, which will be about right there. We have 1, 1, so it'll be here, 1, 1. And we have 2, negative 1, which will be that point right there. Then we get like a straight edge and match the points. Graph the points. So that's my line, y equals to negative 2x plus 3. That's how you graph by plotting points. Okay, now comes, this is a formula here, the slope-intercept form. If a line has a slope m and the y-intercept b, then its graph of the equation is y equals to mx plus b. This is called the slope-intercept form of the equation of the line. Okay, y equals to mx plus b. So m is my slope, and b is the y-intercept. That's what this definition means here. Okay, that's really simplifying it. And the b or the y-intercept is a starting point when graphing, and you start at 0b, right? So whatever the b is going to be 0b, and that's the y-intercept. Okay, now the slope of a line through 2 points, point x1, y1, and x2, y2, where x1 cannot equal to x2, is defined as a quotient of the change in y and the change in x. So this is a formula for the slope, or the m. Y equals to m equals to y2 minus y1 over x2 minus x1. Also the rise over the run. Okay, this is when you're graphing, but this is to find my slope. So let's do an example here. There are 4 different linear graphs. Okay, this is going to be positive slope. right? Because it's going up from left to right. Y equals to mx plus b. This will be negative slope, right? Because it's going down from left to right. That will be y equals to negative mx plus b. The slope is negative, right? My m is negative. The b can be plus or minus, right? In this case, the b is -2, right? But I mean, I forgot to put it, the plus or minus. It can be also plus or minus here. But the most important thing is that if it's going from left to right, if it's going up, it's positive. If it's going down from left to right, it's negative. Now, if you have a horizontal line, that's going to be zero slope. And the equation will be something like y equals to b, and b can be any number. All right, it's going to be a horizontal line. When you have a vertical line, the slope is undefined. And the equation will be x equals to c, and c can be any number. And I let b and c be any real numbers, right? You have to signify what b and c are, right? They can be any number, any real number. Okay, so again, this is positive slope on the left. The second graph is negative slope. The third graph is zero slope because the lines are horizontal. And lastly, the last graph is undefined slope because the line is vertical. Okay, now let's graph y equals to -2x plus 3. But let's use the slope-intercept form. Okay, so that's my slope-intercept form. So I have to know what the m is, my m, right? And I have to find the b, right? My m is -2, which means it's going to go down 2 and 1 to the right. And my b is my y-intercept, which is going to be 3. That's my b. So my b is 3. So the y-intercept is 0, 3, and that's my starting point. Okay? So again, what's my starting point? 0, 3, right? That's my b. So my b will be right here at 3, 0, 3. Then from this point, 0, 3, I'm going to go down 2, which will be 1, 2, and 1 to the right. Will be about right there. And I connect the points, and that's my line. Okay. Now let's graph y equals to 3x minus 5. So my slope is going to be 3, right? Which would be positive 3 is going to be 3 up and 3 to the right. I mean 3 up and 1 to the right, I'm sorry. And my y-intercept is going to be -5, right? And this is my starting point. So let's start at 0, -5, which will be down here, 0, -5. Then I'm going to go up 3. Let's go here, 1, 2, 3, and 1 to the right. And I connect the points. That's my line. Okay. Now let's grab y equals 4. My slope, right? My slope is going to be 0, right? Because there's no x, right? So there's no x, it's going to be 0. And my y-intercept, my b is going to be 4. So that's my starting point, 0, 4. And recall from the second or the third slide that I said when the lines are horizontal, it's going to be 0 slope, which would be y equals to a number, right? Y equals to 4. So we're going to go to 0, 4. And the line is going to pass through that point there, horizontally. That's my line. Observation. When the equation is y equals to a number, right? I mean, the number sign means any number. Then the horizontal line is at that number. Okay? So for example, here y equals to 4, so the horizontal line, it goes through 0, 4. Now let's do number 5. The graph of x equals to -2. Solution. My slope is undefined, right? Because recall from the second slide, when you have a vertical line where x equals to a number, right? X equals to -2, the slope is undefined. So it's going to be a vertical line at x equals to -2. So we go here to -2, and we're going to do a vertical line there. Okay, now observation. When the equation is x equals to a number or x equals to any number to a constant, the vertical line will be at that number or at that constant. Now graphing linear equations. Now this is not in the slope-intercept form, right? So the first step is that we have to rewrite it in the proper form, in y equals to mx plus b, which means we have to have y by itself on the left side, and everything else has to go to the right. So we start by adding 5x to both sides. So we add 5x to both sides, we're going to get negative 2y equals to 5x minus 10. Then we divide by negative 2. I mean to both sides, so negative 2 divided by negative 2 will give me my y. 5 divided by negative 2 will give me negative 5 over 2 over 2x. And negative 10 divided by negative 2 will give me a 5. Now let's graph it. My slope is negative 5 over 2, which means 5 down and 2 to the right. My b is my y-intercept, which will be 0, 5, and that's my starting point. So 0, 5 starts up here, 0, 5. Right there. Then I'm going to go down 5. 1, 2, 3, 4, 5, and 2 to the right. 1, 2. There's my point. So we connect the points, and that's my line. Okay, now here are another graphs, right? This is positive slope, this is negative slope, this is zero slope, and undefined slope. Okay, now write the line of the graph in slope-intercept form. So here you can remember that we need to find the m, which is a slope, and we need to find the b, which is a y-intercept. Solution, right? That's my equation. Need to find m and b. My m is my slope, rise over run, and my b is the y-intercept. So on number 7, my b, right, the y-intercept is going to be 1, right there. 1. So this goes up, right? So I have to find another point that goes exactly to one of the corners here. For example, we cannot use that one, we cannot use that one, nor that one. This is the one we're going to use here. I can use that one, this point here, or I can use the one back here. So let's use this one here. Right? So the rise is going to go up, let's see, 1, 2, 3, 3 up, and 1, 2, 3, 4, 4 across. So this is 3, this is 4. So the rise is 3, and the run is 4. So that's 3, 4. That's my slope. So I found my m, my b is 1. So now I have the m and the b to plug it into the equation to find the linear equation in slope-intercept form. My m is 3/4. There it is. My b is 1. So that's my equation. Now there's number 8. On number 8, I know the slope is going to be negative, correct? Because it's going down from left to right. So where's my y-intercept? My y-intercept is right here at negative 2. Now I have to find another point that goes exactly to one of the corners. Let's see this one here. It doesn't. It goes all the way over here. It's this one here. Right? Rise over run. So this one, right? So from here, right from this point here, is going to go down 1, 2, 3, 4, 5, and 1, 2, 3, 4 across. So 5 down and 4 across. So my slope will be negative 5 over 4. And the b is negative 2. So I found the m and the b to plug it in and find the equation of the line in slope-intercept form. There's my m, negative 5/4, and my b is negative 2. Now number 9. Number 9, right? Number 9, I know it's going to be zero slope because the line is horizontal. So my b is negative 3. And here, guys, right? There's no slope, right? But remember the observation: when you have a horizontal line at y equals b, then that's my equation: y equals to negative 3. Number 10. Remember the observation for vertical line. So it's going to be x equals c, and whatever the c is, I mean whatever the vertical line is, that's going to be my C. So this is going to be 4, x equals 4. X equals 4 because every point is for something. For example, this is for 0. That's for 1, for 2, for 3, for 4, for 5, and so forth. That's why it's going to be x equals to 4. Okay, now, I believe I grabbed this one earlier using the slope-intercept form. There's another way to graph it by finding the x and y intercept. Okay, here. To find the x-intercepts, we're going to let x equals to, to find the x-intercept, we're going to let y equals to 0 and solve for x. In a similar fashion, to find the y-intercept, we let x equals 0 and solve for y. So first, let's find the x-intercept. We let y equals 0, right? So y is 0, right? Y is 0, so we plug in 0 there. So we get negative 5x equals to negative 10. We divide both sides by negative 5. So this becomes x equals to 2. So my x-intercepts will be 2, 0. Now let's find, right, 2, 0 is right here on the graph, right, 2, 0. Now let's find the y-intercept. To find the y-intercept, we let x equals 0 and solve for y, right? So this is my x, so I'm going to let x equals 0, plug in the 0 there. We divide both sides by negative 2. And y equals to 5. So that's my y-intercept will be 0, 5. So then we plot those 2 points and we make our line. 0, 5 will be about right over here on the graph, 0, 5, and we connect the 2 points. That's my line. Okay, now I have another way to do it, right? To do by graphing by using the x and y intercept. Okay, now solution. Find the x-intercept, right? We let y equals 0. So if we let y equals 0, we can cover the negative 4y, right? Because if y is 0, this will be give us 0 here. So let's cover that one, right? Because it's gone. Because again, if y is 0, that the y will be eliminated. It will be 0. Now in our heads, we can divide both sides by 3. So x equals to 4. So my x-intercept will be 4, 0. Right, the 4, 0 is over here on the graph. I just graphed it. Now let's find the y-intercept. So for the y-intercept, we're going to let x equal 0 so we can cover the 3x because that's going to be 0. And then in our heads, we can divide both sides by negative 4, so y equals to negative 3. So the y-intercept will be 0, negative 3. So let's plot that point. Now we connect both points. That's my line. When I teach this class and I do it this way, I call this a cover, right? Because we cover the y and then we cover the x. I just gave it that name, the cover method. Okay, but this is not in the book. I just made it up so students can have a better understanding. And at times it works, and at times students like the way it's explained in the book. But I always have different ways to explain the material. Okay, now finding the slope of a line through 2 points. So for these next 4 problems, all they want you is to find the slope. So then the slope is equal to y2 minus y1 over x2 minus x1. So since this is my first point, I want to call this my x1. x1 is 9 and y1 is 0. So x2 is 12 and y2 is 12. Right, there's my x1, y1, x2, and y2. So f is equal to y2 minus y1, right? So it's going to be 12 minus 0 and 12 minus 9. So it's going to give us 12 over 3, which my slope is going to be 4. Okay. Now number 14. Again, so my x1 is negative 5, my y1 is negative 2, my x2 is negative 4, and my y2 is 11. So y2 will be 11 minus negative 2, and negative 4 minus negative 5. This will give us 13 over 1, which will be 13. That's my slope. Okay. number 15. So again, in a similar fashion, right? So my x1 is going to be 5. My y1 is going to be 3. My x2 is going to be -7. And my y2 is going to be 3. Just plug them in to the formula. So y2 is 3 and y1 is 3. So 3 minus 3 over -7 minus 5. It will give us 0 over -12. Okay? Okay, now guys, I tell students that always look for the observation first. This way you don't have to do all the work and you know exactly what the slope is. If, okay, for example, when the y's repeat, right? For example, you see here on point 1 and point 2, the y's are the same. So when the y values repeat, it's going to be 0 slope. Okay? This is number 16. So x1 is 1, y1 is 2, x2 is 1, and y2 is -6. So we plug him in, right? So y2 is -6, y1 is 2, x2 is 1, minus x1 is 1. This will give us -8 over 0, so this will be undefined. Observation. When the x values repeat, it's going to be undefined slope. So it's always wise to first, when you're looking for the slope or finding the slope between 2 points, it's always wise to check the x values if they repeat. If they repeat, the slope is undefined. If the y values repeat, it's going to be 0 slope. And if nothing repeats, you actually have to work it out. Okay. Okay. Now this is finding the equation of a line. This is called the point slope form. If a line has a slope m and passes through the point x1, y1, then y minus y1 is equal to m, parentheses, x minus x1, close parentheses. That's how you find, that's how you use the point slope formula to find the equation. So here, guys, you need to find the slope and 1 point to find an equation of a line. So for example, on number 17, they gave us a point and they gave us my slope, my m. Right, so let's plug in the y1 is going to be 2. My x1 is -3, my y1 is 2, and my m is 4. So we plug them into the formula. And then here we're going to, here we have to simplify. This is going to be x plus 3. Then we distribute. So y minus 2, this will be 4 times x will give us 4x, and 4 times 3 will give us 12. Then we're going to add 2 to both sides. So we have 4x plus 14. So that's the equation of the line in slope-intercept form. Okay, here's another one. Okay, so first we need to find the slope. So again, for this one, they didn't give you the slope. So you have to find the slope, all right? And so we're going to use what we learned earlier to find the slope. And then we're going to use the point slope formula to find the equation. So again, let's check if the x values repeat. They don't. Let's check if the y values repeat. They don't, so we have to do the work. So x1 is equal to -5. y1 is -2. x2 is -4. And y2 is 11. So we plug them into the formula. It's going to be 11 minus -2 and -4 minus 5. So this will give us 13 over 1. Right, which will be 13. So I found my slope. Now x1 is -5 and y1 is -2 and my slope is 13. So plug him into the formula. My y1 is -2, my x1 is -5, and my m is 13. So I'm going to distribute now. So I'm going to get y plus 2 equals to 13x plus 65 because 13 times x is 13x and 13 times 5 is 65. Now I'm going to subtract 2 to both sides. So I get y equals to 13x plus 63. This is my the equation of the line in slope-intercept form. Okay, now we're going to cover parallel and perpendicular lines. Okay, two non-vertical lines are parallel when they have the same slope. So parallel lines have the same slope. Two non-vertical lines are perpendicular whenever the product of their slope is -1. An equivalent definition of a perpendicular line is non-vertical whose slopes are negative reciprocals of one another. It means that if the slope, right, say that you have a positive slope, so the perpendicular slope will be the opposite sign, and then you do the reciprocal of the regular slope. Okay, right now I'll show you an example of those. For example, these lines are parallel. Why? Because the slopes are the same. Same slope. They're both, the slopes are both 3. These are also parallel because the slopes are the same, which are -2. Okay, now, here's an example of perpendicular lines. Right, for example, these are perpendicular lines because this is 3, this is the reciprocal of 3 is 1/3, and we do the negative reciprocal means, right, this is positive, this is negative, right, and then the 3 we invert it or do the reciprocal, which will be 1/3. Or we can do what it says here on the definition. If the products of the two slopes must equal to -1, right? 3 times -1/3, right? 3 times -1/3 will give you -1. Okay, now, these are also perpendicular because we have 5/4, and then, right, we have the opposite sign, and the 5/4 we flip it or we do the reciprocal. So these two are also perpendicular. The product of the slopes is -1. Right, because 5/4 times -4/5 is equal to -1. Okay, now, this is number 19. It says find an equation of the line with the given conditions. It passes through the point 3, 4 and is parallel to 4x minus 2y equals to 5. So the first thing that we have to do here is that we have to find the slope of this equation here, of the line here. Okay, so how do we find it? We have to rewrite the 4x minus 2y equals to 5 into the proper form. Okay, again, here are the solutions. First, find the slope of the line by rewriting it in the slope-intercept form. And then after that, we use the point slope formula. So here, I'm going to subtract 4x to both sides. So I have -2y equals to -4x plus 5. Then I divide by -2. So I get y equals to 2x minus 5/2. So if it says right parallel, then my slope here is going to be 2. Then I have my slope and I got my point. Now we have right my slope and my point. So the 3 is y1, the 3 is x1 and my 4 is y1. So plug him in. It'll be y minus 4 equals to 2x minus 3. Now here, we're going to distribute. So I get 2x minus 6, and now we're going to add 4 to both sides. So y equals to 2x minus 2. So this is the equation that we're looking for. The line, the equation of the line in slope-intercept form. Now this can be done another way, right? If you want, you don't have to use this formula here. Let's stick to y equals to mx plus b, right? We have my m. My m is 2. Now I need to find b. So if we solve for b here in the formula, right, we subtract mx to both sides. So b equals to y minus mx, right? This is to find b. So you always use b equals to y minus mx. So I got my x1, my y1 from the point, and I got my slope, which is my m, which is 2. So just plug him in here. So b equals to 4 minus 2 times 3, right? Because my y is 4, my slope is 2, and my x is 3. So b equals to 4 minus 6, b equals to -2. So I have my slope is 2, my b is -2, so plug him in there. You see, guys, I have the same line as as here on top. So you can use either one to find the equation of the line. Okay. Okay, now this is number 20. It says find an equation of the line with the given conditions. Passes through the point 6, 8 and is perpendicular to negative 2x plus y equals negative 3. So again, I need to rewrite the equation in proper form. Then we're going to get the slope. And then we're going to plug it into the point slope formula. So let's start. So we're going to subtract, we're going to add 2x to both sides. So we get y equals to 2x minus 3. My slope is 2. Okay, now what's the opposite reciprocal? The opposite reciprocal, right? So this becomes negative, and then the reciprocal of 2 is 1/2. So this is negative 1/2 is the slope perpendicular to this line here, to the line negative 2x plus y equals negative 3. So I have my slope, I got my point. Right, and my slope is negative 1/2, so we plug him in there. Now y minus 8 equals to negative 2x minus 6, so now we distribute. So we get negative y minus 8 equals to negative 2x plus 3. Then we can add 8 to both sides. So we get y equals to negative 1/2 x plus 11. That's the line. This line is perpendicular with a given condition that passes through the point 6, 8. So this is the line that we're looking for. Okay, now, how do we apply what we just learned in an applications problem, like a word problem? Okay, we can do it in the number 21 here. Here it's saying the manufacturer's suggested retail price, which is called the MSRP, for a base model 2016 Toyota Prius is worth $25,035. And it is expected to be worth $14,115 in 4 years. So for A part, they want you to find the linear depreciation function of for this car. And then for B, we're going to estimate the value of the car in 5 years from now. And C, at what rate is the car depreciating? So first, I need to find my 2 points. Okay? Need to find 2 points. So when the car is brand new, right? In 2016, the car was brand new, right? So no time has passed. So x equals 0 corresponds to the original price. So y equals to 25,035. So the first point will be 0, 25,035. Now, for the second point, in 4 years, a car is worth 14,115, so x equals to 4, and y equals to 14,115. That's my second point. Now, we're going to find the line, right? The linear depreciation function. Need to find the slope and the y-intercept. So I know this is y1, x1. The y1 is 0, the x1 is 0, and the y1 is 25,035. The x2 is 4, and the y2 is 14,115. So it's going to be 14,115 minus 25,035 over 4 minus 0, which gives us negative 10,920 over 4, which gives us negative 2,730. That's my slope. That's my m. Now I'm going to use b equals to y minus mx. Okay, I'm going to use the first point. My y is 25,035. My x is 0. And my m, we just found it, which is negative 2,730. So plug it into the formula. So we're going to get 25,035 because negative 2,730 times 0 will give us 0 on the right side. So that's my b. So I found my b, And I have my slope. That's my slope. That's my y-intercept. So plug it into the formula. So this is a linear depreciation function. So that's the answer for part A. Okay. Now for part B, we're gonna evaluate the value of the car in 5 years from now, which means I'm gonna evaluate f of 5, which means I'm gonna plug in 5 for every x, which is right there where the x value is. So f of 5 is 11,385. So this is the answer for part B. The car will be worth 11,385 in 5 years. At what rate is the car depreciating? For C part, they're just saying what's the slope. But here, guys, you have to be real careful because depreciating means that it's negative, right? So you don't have to put the negative. So the answer for C will be 2,730. Okay, so that's the answer for C. The car is depreciating at 2,730 per year. Okay, now, now number 22, we're going to evaluate functions. When you evaluate a function, all you do is, for example, on A, they give us f of x equals to x squared minus x plus 4. We're going to evaluate f of negative 2, f of 5, f of x plus h, and D, f of x plus h minus f of x over h. Let's start with A. F of negative 2 means that we're going to plug in negative 2 for every x, right? Which is going to be here, right, where the x squared is, and also for the x. So they will give us, we're going to plug it in there, and also here for the negative x. Now we evaluate, so that'll be 4 plus 2 plus 4, so the answer is 10. So when x is negative 2, y is 10. Now for B part. Oh, you know what, guys? This is supposed to be a 5, guys. Okay, I put a 3. My bad. There's a mistake there. So that's supposed to be a 5. We're going to plug in 5 for every x. I believe I was using 3, but then I got the same answer as 10. That's why I decided to take out the 3 and put a 5 instead. And I didn't change it here because it would have given us also 10. Okay, that's why I wanted for it to give us something different. That's why I changed it. So f of 5, I'm going to plug in the 5 here for the x squared and also the 5 here for the x. This will give us 25 minus 5 plus 4. So the answer will be 24. So f of 5 is 24. Now let's find f of x plus h. Here's where a lot of students begin to encounter some issues here. But this is not that complicated. All you do is keep doing what we're doing over here. So here, guys, I'm going to plug in x plus h for every x. So I'm going to plug it in here for the x, and also here for the negative x here. Now I need to FOIL this. X plus h squared. Okay, I'll do it here on the side. X plus h squared is equal to x plus h times x plus h. So if we FOIL, for example, x times x will give us x squared. X times h will give us xh. And h times x will also give us hx, or xh is the same thing. And h times h will give us h squared. Now we can combine these, right? So we're going to have x squared plus 2xh plus h squared. So this will replace the x plus h squared. Now let's put minus x plus h plus 4. So here, guys, right? So this, the negative x plus h plus 4. So that means that we're going to distribute the negative 1 times x will give us negative x. Negative 1 times h will give us negative h plus 4. So this is your solution because you cannot combine any of the terms. They're not like terms. So that's the answer that we're looking for. Now for D, this is called find the difference quotient. This is part D. So again, I'm going to do it in 3 parts. The first part, I need to find f of x plus h, right? Which I already did it in the previous slide. But let's do it again. So I'm going to plug in x plus h for every x. Now I'm going to simplify the x plus h squared, which will be x x squared plus 2x plus h. This will give us negative x minus h, right, plus 4. So this is the answer for the first part, for x plus h. Now, the second part, I'm going to do the f of x plus h minus f of x. Right? I already found the f of x plus h, right, which is this part here. Minus f of x is the original function, which will be x squared minus x plus 4, right? That's f of x. Now here, I'm going to distribute the negative, right? Like this would be x squared plus 2xh plus h squared minus x minus h plus 4. Here's where I distribute the negative. Negative times a positive will give us negative. Negative times a negative will give us a positive. And negative times a positive will give us a negative. Now for here we can combine some of the terms here. Here's a hint. The terms that don't have an h have to be eliminated. Okay, for example, does the x squared have an h? No, it doesn't, right? So somewhere has to be a negative x squared. You see, and here it is right here. Does the 2xh have an h? Yes, so that one stays. Does the h squared have an h? Yes, it does, so it stays. How about the negative x? Does it have an h, the term? No, it doesn't, so there's going to be a positive x somewhere, which is over here. Those cancel. Does the negative h have an h? So it stays, right? Anyway, there's no other h that you can combine it with. That's why I know that every term that doesn't have an h has to go. Does the 4 have an h? No, right? So it's over here. So these two also cancel. So what's left is 2xh plus h squared minus h is the answer for the second part. Now the third part is everything together. Oh, here, guys, I did something else here because I know that I have to cancel the h on the bottom. So the top part is here. I just did it, right? So now I can cancel the h's. So this is my solution that we're looking for. 2x plus h minus 1. For this type of problem, students, you have to practice. And all these hints here will let you know that you're in the right path. For example, once you simplify these right here, right, this part here, and if you have something with an x left by itself, you're doing something wrong. So every term that's left has to have an h. Because this way, I can factor out the h, so I can cancel the h on the bottom. Okay? Okay, now we're doing quadratic equations, right? So I think I'm going to show you like 3 or 4 more examples. So we have number 23. F of x equals to x squared plus sin x plus 9. Here they want you to find the vertex, the axis of symmetry, the y-intercept, and x-intercepts, and then they actually want you to graph it. But you graph it by plotting all the points and doing the graph according to the points that you plot. So solution, right? So first, you need to find the vertex. This is how you find the vertex. Negative b over 2a and f of negative b over 2a. This is my x value. This is my y value of the vertex. The axis of symmetry is x equals to negative b over 2a. So once you find the vertex, you also find the axis of symmetry. For the y-intercept, is real like obvious. The y-intercept is always a constant. Okay, the constant is a number that doesn't have an x or a variable. And then for the x-intercepts, you have to know how to factor. Okay, so let's start with the vertex. My a is 1 and my b is 10. So negative b over 2a is equal to negative, right? So b is 10 and a is 1. So plug it in there. This will give us negative 10 over 2, which will be equal to negative 5. So that's my x part of the vertex. Now, for the y part, all we do is plug in what we found, found the negative b over 2a, plug it into the original function to find the y part of the vertex. Right, so I'm going to put the negative 5 here for the x and negative 5 here for the x here. Negative 5, negative 5. This becomes 25. This becomes 25 minus 50 plus 9 will give us negative 16. Because negative 5 squared will give us 25. 10 times negative 5 will give us negative 50. So 25 minus 50 will give us negative 25. And negative 25 plus 9 will give us negative 16. So this is my vertex. Once you find your vertex, you also found the axis of symmetry. It's going to be x equals to negative 5. The y-intercept is a constant, which will be 0, 9. Right? That's always your y-intercept. For the x-intercepts, we got to factor, right? So to factor, we have to let y equal to 0 and solve for x. So this will be x plus 9 and x plus 1. I believe I'll be showing you guys how to factor next week. But for now, guys, you have to know how to factor to eventually to know to find the x-intercepts. So then it'll be x plus 9 equals 0 and x plus 1 equals 0. So here we have x equals to negative 9 and x equals to negative 1. So these are my x-intercepts. Negative 9, 0 and negative 1, 0. Then all you do is plot them to do the graph. Okay? But I believe I didn't graph this one because I couldn't find a graph that will graph this equation here. Maybe I can find it for the next presentation that I do for summer 2. Maybe I can find the graph. Now, find the vertex, axis of symmetry. This is the same thing, but this is a quadratic equation in another form. So this is a form, right? So my vertex is going to be HK. My axis of symmetry is going to be x equals to h, right? Which is the x part of the vertex. For the y-intercepts, we let x equals 0 and solve for y. And for the x-intercepts, we let y equals 0 and solve for x. Okay, so let's find the vertex. Because the vertex is very, very obvious, right? So remember, if it's negative here, it's going to be positive here for the h. And the k is how it is. So here, guys, right? So this is positive, so my h is going to be negative. So it's going to be negative 3, negative 16. This is my vertex. And my axis of symmetry is the x part of the vertex, which would be x equals to negative 3. Right? That's your vertex. X equals to negative 3. Now for the y-intercept. For the y-intercept, we let x equals 0. So this is the same thing as y, right? So this will be the same thing as y. So let x equals 0. So we're going to put in the 0 here. So 0 plus 3 is 3. 3 squared is 9. 9 minus 16 will give us what? Negative 7. So that's my y-intercept. For the x-intercepts, we're going to let y equals 0. Right, so this is like my y here, y equals 0. So now I'm going to add 16 to both sides. Now I'm going to take the square root of both sides. Right, so I just switch because I like to have the x on the left side. So I take the square root of both sides. So the square cancels the square root. We have x plus 3 equals to plus or minus. The square root of 16 is 4. We subtract 3 to both sides. So we have negative 3 plus 4 and negative 3 minus 4. So negative 3 plus 4 is 1. And negative 3 minus 4 is negative 7. So these are my x-intercepts. Negative 7, 0, and 1, 0. And then to graph it, all you do is plot the points and do your parabola. Okay, now I believe this is the last one. How do you apply quadratic equations in like a real-life situation? Okay, here's how you do it. It says the revenue for McDonald's Corporation in billions of dollars for the years 2015. Hey guys, I also did a mistake here, guys. This is supposed to be from 2010 to 2015. So I need to make that correction there. Can be approximated by the quadratic function r of x equals to negative 1/2 x squared plus 13x minus 57, where x equals 10 corresponds to the year 2010. So this should have been 10 here, 2010. So for A part, I want you to find the vertex. So my A is, right, this is negative 0.5 or negative 1/2, and my b is 13. So let's put it into the formula. So negative b over 2a will give us negative, right? My b is 13. Plug it in there. There's my 2, and my a is negative 0.5. So this gives us negative 13, or because 2 times negative 1, negative 0.5 will be negative 1. Negative 13 divided by negative 1 will give us 13. Now to find the y part of the vertex, we plug in 13 to the original function. We plug in the 13 there for the x squared and also where the 13 is. So, right, if we put in the calculator, it's going to give us 27.5. So my vertex is 13, 27.5. Now, for B part and C part, once you find the vertex, the answer for B is the x part of the vertex, and the answer for C is the y part of the vertex. Okay? So this is the answer for A, my vertex. The answer for B, in what year does this period was the revenue at the maximum? Is going to be x equals 10, corresponds to 2010, right? So x equals to 13, right? Because this is 13, corresponds to the year 2013. So the answer will be in 2013, the revenue was the maximum. Now for C part, what was the maximum revenue to the nearest billion? We get the y part of the vertex. Okay, the y part of the vertex is the maximum revenue, but I want you to run that out to the nearest billion. So it's going to be 28. So the maximum revenue is 28 billion. Okay. I know that some of you guys that are barely, this is your first semester in school. Maybe this part one was a little bit, I didn't go in detail, because if I go in detail, I mean, I will not finish in an hour. But if you have any questions, you can always go to tutoring, and they can help you with some of the homework. Okay. Do you guys have any questions? So I believe we're done, and it's right at 4 o'clock, I believe. So let me go back to the screen. And I guess that's it for this PowerPoint, for this presentation.
Thank you, Mr. Isasi. Thank you all for coming. Please join us next Friday as we continue with our Happy Math Hour, June 10th at 3 p.m. for the Math 1324 Factoring Exponential Equations and Logarithmic Equations, and for Math 1314 Standard Form of Quadratic Equations, Graphing, Synthetic Division, and Finding Zeros. We do want to remind you all, thank you, Mr. Isasi. We do want to remind you all about our previously recorded sessions, which are available on the YouTube playlist, and the session will also be available on that playlist later today. Please know, as Mr. Isasi mentioned, we do have online tutoring open now and available through our Blackboard Collaborate Ultra, 7 days a week from 9 a.m. to 11 p.m., Monday through Sunday, and face-to-face tutoring is available Monday through Friday, 8 a.m. to 5 p.m. Thank you very much, Mr. Isasi, for presenting today. Thank you, audience, for coming and being a wonderful audience, and we hope to see you soon. Bye now.